Okay, couple things. A, I have not graded your tests. B, I have looked at your tests. And C, I'm not happy. Let's just say it nicely. Factoring is so important. If you don't know how to factor, then chapter 5 is not going to work for you as well, because chapter 5 is all about factoring. So you really need to ask yourself, how much homework have you done, if any? How many videos have you watched, if any? And if you have problems with the factoring, you know where to find me. I'm always here, virtual office hours, and I'm looking to you on the screen and here in the class. I want you to succeed in this course, but I need some input. I need to get something from you back. So the factoring is important. And as I have looked over some tests, I feel that you need to study more, A, and this is for the people. If you listen to this recording some other time, you're not here right now, you need to attend class. That's like the biggest thing. I mean, we have a pretty good attendance record, but ever since spring break, I feel like it's going down, down, down. And that always happens, unfortunately. So, A, I want you to come to class. B, I want you to listen to this recording. C, I need you to do what? Homework. Homework. Practice. D, if you have questions, I'm always waiting for people online, virtual office hours, and even if I don't have virtual office hours, like this morning, I was helping somebody online. So it's not necessarily the time is set in stone. If I got a minute, I'm there for you. So I need you to look at the factoring again. What I'm trying to do is the people who took the test in class, I will scan the test and I will upload it to our Falcon Online, obviously to the assignment. So just that you can see it, nobody else can see it, obviously. So I will upload and I will give you some feedback on the test. And of course, it's totally optional. Test, I'm looking not in the camera, test corrections. If you want to get some points back, then you have to turn in test corrections. What else do I want to say about that? Test corrections, discussions. Discussions, if you missed some, I told you I will open them again the end of the semester, but that's not a free pass. Like, I don't have to do any now. She's going to open them again in May anyway. They are there to help you, to get you going as a resource for factoring and so forth. So I need you, whatever tests we have, whatever discussions we have, work on them. And if you do have a bad grade on them, then you have the chance to redo them at the end of the semester. We still have chapter 5 test, we have 6, 7, 8 test, and we have the final exam. So there's still a lot of points to be accumulated, and of course the final exam will replace your lowest test grade. Any comments from you guys online? Study. Nobody wants to say anything? Study, come to class and do your homework and watch the videos. And
You
come
said
and
the
see
final
me, of
exam
course,
replaces our
first and
lowest grade.
foremost, come and see me. Danielle, did you? I forgot to scan my homework. Aww. Okay, Elijah, I will get back with you. You cannot. Mark, I'm not going to answer that question. We're talking about intermediate algebra and not other teachers. One thing at a time, one day at a time, right? No, it's okay. I'm just kidding. Come and see me in person. Of course, everybody is great. Where was I going with this? I lost my train of thought. Yeah. So Mark, when you come to class, we can talk about that. Yes, please. Since Mark is mentioning it, signing up for other courses. The light is really bright. I have migraines. I gotta turn the light up a little bit. Sign up for summer or fall classes. They are open now. What happens if we fail the exam? And Danielle and everybody else. If this is your exam, you have a low score, the final exam, and if it is a higher score, will replace this exam. Yeah, so I'm not worried about it for right now. Okay, Danielle? And if you have questions, just email me individually. The lowest chapter test will be replaced with the final exam grade. Of course, it has to be higher, right? Because if it is lower, then it makes no sense. So if you have a 40, let's say, on any of the tests, not necessarily does it have to be this one, and this is your lowest test score, and you have a 90 on the final exam, then your 40 will be replaced with the 90 that you hypothetically had on your final exam. And the final exam is totally multiple choice. 30 questions. Okay, we got to get going because we have stuff to do. Now, again, Chapter 5 is on rational expressions, rational equations. Now, this is usually the chapter that students have not seen before, because I'm pretty sure at some point in time in your math career, you have done factoring before. You have done linear equations before. Does not necessarily mean that you remember how to do it, but you have seen it before, I'm pretty sure. Now we're talking about rational expressions, and you may have not seen this one before. So it's double important to pay attention, to do your homework, to ask me questions, to come and see me, and to do whatever it takes. Like I said, please. Maybe I'm more upset than sometimes I want you to be good, move on, go to college algebra, whatever class that you need to take. 5.1. So a little bit about rational expressions. Why do students not like it that much? And I can tell you it's all about fractions. Oh yeah. Fraction action. Yeah, I probably can see your faces now too. What? Fractions? Yes. Fractions on steroids? No. Fractions that involve an x, variables, long expressions in form of fractions. And guess what we're doing with those rational expressions? We're going to reduce them just like fractions. We're going to multiply and divide them. Remember your fractions. Fractions are our friends, right? Yes, they are. They will be. Adding fractions with different denominators. Ooh, remember that? LCM and all this good stuff? Yeah, now we have variables in the denominator. How do we find the LCM of this? Well, I'm going to teach you. And we're also going to solve rational equations. So a rational expression, I have some examples here, really in the form of a numerator and denominator, but now you have a polynomial. Something is in my pocket that's bothering me. Oh, it's a hair tie. Duh. You have polynomial in numerator and denominator. Now, what's the difference between a rational expression and a rational function? Well, a rational function, has f of x. So a rational function has a label, so f of x equals x plus 5 over x minus 9. That's a rational function. Rational function. An expression really is just a polynomial x squared minus x minus 6 over 5x plus 2. That would be a rational expression standalone all by itself. And here it comes. So this is an expression, a rational function when you have the f of x in front of it. My computer's acting weird. Okay, be right back. Thanks for letting me know. Now, towards the end of this chapter, we will talk about x plus 5 over x plus 1 over x plus 3 equals, I don't know, I just so made that up, how to solve, and this is called a rational equation. So we have a rational expression and we have a rational equation. What's the difference between the two, ladies and gentlemen? Students, difference between a rational expression and a rational equation. Please put it in the chat. Why does the chat show up over? Oh, you know what? Nobody, are you guys? I haven't shared the screen with you. Nobody said anything. You just are happy you didn't see the math? Because I just saw something weird. I'm like, how come it's been over here? Okay. Hold on. Now I gotta get the Siri back up. And the IT guy just emailed me and said, is it good now? No. No, I can't even. Let's try this again. Section, where are we at? 5.1. Okay, now can you see it? The one mark is correct. Why? That's my day this morning. Let's do one more time. Good thing I'm recording it. There you go. Can you see it now? I hope so. So what's the difference between a rational expression and a rational function? Here we are. Rational expression, rational function. Mark says one has an equal sign, and that is exactly correct. So that's the difference between the two. So if you're being asked sometime in the future, like for a test, give me an example of a rational expression and give me an example of a rational equation, you know that the difference has to be an equal sign. So pay attention to that one. So now, again, this is the definition. You can see it in the book. A rational function has the form of a polynomial in the numerator and in the denominator. That's just math language for a rational function, but we know we have some kind of either binomial, trinomial, whatever it is in the numerator, and some polynomial in the denominator. And you can see that on page 380. Now, here's an example of a rational function. On the right-hand side, I have another example of a rational expression. So rational function x plus 2 over x minus 3. We have done this before, function notation. So how do we evaluate f of 1? F of 1 means, let me refresh your memory, that you replace the x with 1. So here's our original rational function. Instead of x, we're going to say 1 plus 2 over 1 minus 3. Each x that you see in the function, you're going to replace, and then you do the arithmetic. In the numerator, you get a 3. And in the denominator, you have a negative 2. Everybody with me? You plug in 1 for x. Yes, Mark, thank you. So guys, go ahead and find f of 0. What is f of 0? Same original function again here, f of 0. Mark's given me an answer. Somebody else? Danielle? F of 0, what do I hear over here? 0 plus 2 over 0 minus 3 is indeed negative 2/3. Yes. Negative 2/3. Okay, let's try f of 3. So we're replacing the x with 3. What do you get now? Mark says 5. Anybody else? Let me replace it. 3 plus 2 over 3 minus 3. 3 plus 2 is 5. Danielle says 5 over 0, and Elijah says 7/2. So we add the numerator, we get 5, and 3 plus 3 minus 3 is indeed 0. What is, Tatiana says it correct. What is 5 over 0 when you have a 0 in the denominator? That is, Tatiana, say it, undefined. So every time you get a 0 in the denominator, this function is undefined. If you think back to chapter, when was it? 2. Chapter 2, we talked about functions. And we we actually talked about rational functions before and how to find the domain. Remember domain again? This problem, a similar problem, actually was on that test. I think it was chapter 2 or 3. We talked about domain, so this rational function here is undefined when x is equal to 3. So the domain are your x values. So in English, that would mean the domain is all real numbers except, can spell, except x equals 3. Because for that, we did not get a y value, we got an undefined. Who can remember how we wrote this domain in interval notation? Because that's what we did. And I remember exactly that you had a problem. You had to say if it was quadratic or linear, then you had to find the y-intercept, and you had to find the domain. How did we write the domain? Let me just show you on the number line. 3 is bad, but everything to the left of 3 and everything to the right of 3 works. 3, x equals 3, I actually gave that a name. I called this the restricted value. Who remembers on how to find the domain for a rational function? We said over to the left we have negative infinity, and all the way to the right we have positive infinity, and Danielle is exactly correct. Negative infinity to 3 union 3 to infinity. This is a two-part domain in interval notation. Remember? Yes, yeah. We did this in chapter, what chapter was it? 2, 3. Chloe, did you find it?
2.5.
2.5. Here you go. Okay. So we're doing the same thing again. We have to find the domain. And the domain, one more time, is all the x values. We use an x value. We plug it into our function. A y value is coming out. But there's one value where we don't get a y value. We got an undefined. And that, in this case, was 3. Now, just to remind you, 0 over 3, when the 0 is in the numerator, then the answer is 0. If you have 0 over donuts, I guess I was talking about donuts, the answer is 0 as well. 0 over x plus 3, the answer is 0. When the zero's in the denominator, in the numerator, you always get a 0 as an answer. It doesn't really matter what's in the denominator, but if 0 is in the denominator, like 3 over 0, 1500 over 0, x squared plus 3x minus 9 over 0, or donuts over 0, the answer to all 4 is undefined. And undefined is not a numerical value. That's why our domain skips. It skips over whatever the value is that makes the denominator 0. I call this the restricted value. So be careful about this. Look at that again. So how about this one on page 387? They give you a function, number 4, and you have to evaluate this function, if possible, at the values that are given to us. So let's practice this one more time. M of x is x minus 4 over x plus 6. You guys go ahead, find m of negative 6, m of negative 4, m of 0, and m of positive 4. You replace the x with, in the first case, negative 6. Okay, so for the first one, Elijah has an answer. We get, in the numerator, we get a negative 10 over 0, and Elijah said that's undefined. That is correct. M of negative 4. Oh, by the way, Tony Ann has a birthday today. Happy birthday, everybody. Yay. Mark says happy birthday. The second one, -4. Let's find out. We have -4 minus 4, that is a -8. -4 plus 6 is 2. And a -8 divided by 2 indeed is a -4. You are correct. Okay. M of 0, which is -4 over 6. Now let's practice our reducing skills. That would be -2/3. Now that value that we just found, the x value is 0 and y is -2/3. How's that called? Has a special name. M of 0 is -2/3. What kind of point is that? Here you go. You just found the y-intercept. If you had to graph it, we do not graph these functions in intermediate algebra, but if you're going to college algebra, you definitely will have to graph them. And the last one is 0 over 10, which indeed is 0. So this point, this ordered pair would be 4, 0, and that is an x-intercept. Just to refresh your memory. And while we're at the problem, we already know that m of -6 is undefined, so who can help me and tell me what is the domain? The restricted value, the RV, is -6 because that's where we got an undefined. We have a two-part domain, one that's coming from the left, and then we're going to the right, but we're going to exclude -6. Yes, Danielle is typing. Danielle, the only thing I don't like, -infinity to -6. -6 is not a bracket. -6 is a parentheses. A parentheses means the value is not included. So you have to have parentheses here. -6 to infinity. You need parentheses. Okay? Cool. Let's try another one. So there are a couple problems in the book of finding the domain. I kind of went ahead of my notes already. Now the domain are the x values, and we already talked about it. I'm not gonna look at this example here. Let's take a look at this one I made up. F of x equals x squared plus 2x minus 6 over x plus 5. Find the domain. So here are our steps. We have to figure out what is the restricted value. So you set the denominator, strictly the denominator. You don't even look at the numerator. The denominator here is x plus 5, and you set it equal to 0. Are you with me? And we're going to solve. So to solve is just one step. You subtract 5. You get x equals -5. That is the RV. And the last step is to write the domain in interval notation. Now, if your RV is only one value, then your domain, your general form of the domain, is -infinity to whatever the RV is, union RV to infinity. So that's kind of a recipe. But only if the RV is one value. We're about to do a problem where we have more than one. So in this case, the domain would be, who can say it here, anybody?
Infinity.
To yes, you are correct. Tony Ann's correct. Negative infinity to negative 5, union negative 5 to infinity. Definitely something you not only have to know for the next test, but also for the final. I can tell you that already. Now, I don't want to look at that because it's basic. Well, let's do it. Number 10, find the domain. Basically, it's the same type of problem. You set the denominator, which is t plus 3 equal to 0. And if you solve this, you get t equals negative 3. Restricted value. What's the domain now? Domain, anybody? Yes, Tony Ann, go ahead, say it.
Negative infinity, negative 3, union, negative 3, infinity.
Right. Yep. Pretty simple, I hope. Don't forget it. Okay, here comes number 17. 17 in the book is x plus 5 over x squared minus 25. Find the domain. So we're doing the same. We're setting the denominator equal to 0. But here we go. Here it comes. That's where we start to factor again. That's why it's so important that you know how to factor. Now, the factoring methods primarily we use in chapter 5 differences of squares. So if you want to review something over the weekend, I would definitely go over differences of squares, just basic GCF problems, and a trinomial here and there. But that's about it. You don't see that many cubes. You don't see that many AC trinomials either. Grouping, there will be some grouping going on, but mostly difference of squares, trinomials, and in chapter 5, we're not going over the methods anymore since we did that in chapter 4. In chapter 5, I'm just going to factor it. So we have x squared minus 25, which is a difference of two squares. And we factor that into x minus 5 and x plus 5. Remember, that was in 4.8. Now we got to solve. And for solving, we set each factor equal to 0. And we solve the many factors. In this case, we have two RVs. We have a positive 5, and we have x equals a negative 5. So this function would be undefined for negative and positive 5. Let me show you on the number line how this looks like. Let's say we have negative 5 over here, and we have positive 5 over there. We get y values to the left, in between, and to the right. We don't have a y value for negative 5 and 5. So this is really a three-part domain. 1, 2, 3. Who wants to try, people online, to write this in interval notation? And people here as well. You write it down. Let me walk around. Let me see what you got. Domain is a three-part domain. Well, coming from the left is over here, which would be negative infinity, right? And where do we stop? Right in front of the negative 5. Negative 5 not included. So that would be the first part. The second part is in between the two numbers. Elijah, yes, in between the two numbers, which is from negative 5 to positive 5. That's number 2. And number 3, union from positive 5 not included to infinity. So here we have 3 parts. Yes, Nick, that is correct. 3 parts. So when you have a square in the denominator, the general form of the domain would be negative infinity to RV1 union RV1 comma RV2, you know, if you have to, union RV2 to infinity. That's kind of the recipe for that one. And that is as far as we go in this class. 3-part domain. And don't you forget it. Everybody good so far? Ask me questions. What is she talking about? I'm talking about domain. Anybody? Okay, we're moving on. Now, I don't want to go through this again. We already did. How about this last one? Why not? We like it so much. What is the domain? In this case, our denominator is 2x minus 5, set that equal to 0. Then you add 5. 2x equals 5, divide by 2. And our restricted value is just one value here. At 5/2, this function is undefined. So you tell me what the domain here is. Oh, I just thought about something. I don't know if that's the next slide, but if it isn't, I will ask you. Domain. We only have one restricted value. Okay, Chloe, you put your pen down, so I guess you wrote something down.
It's negative infinity, comma, 5/2, parentheses, union, parentheses, 5/2 infinity.
That is correct. Negative infinity, 5/2, union 5/2 to infinity. This is not a 3-part, again, because we only have one restricted value here. Are you guys with me? People online, talk to me. You're not out for lunch, are you? I always say that. I don't know. I just have to say it. Okay. Elijah, I see you on Saturday. I'm wearing red. I have an old Michael Schumacher outfit. If I can fit in it, I will wear it. Okay, moving along. Danielle is typing something. So, okay, here it is. I like this question. Danielle was typing. No, maybe not. No lunch yet. Okay, cool. I give you the domain, and you give me a function. Now I want to see 40 different functions here. This is not one size fits all. I give you a domain and you give me a function. And everybody really should have a different answer. If the domain is from -infinity to 7 and 7 to infinity, that tells you that your RV is equal to 7. So, okay, Ashley, I hope it's working. People, type in a function that has a domain of a restricted value of 7. Let me work around here. Oh, I better touch the iPad before I lose connection again. Okay, that looks good. Any function that has an RV of 7. Okay. Yep. So, yep, there you go. 7 something. Yep. I like how Sonia, I was walking around, and Sonia started with the denominator, and she wrote out x minus 7. That is exactly correct. Do I care what is in the numerator? Absolutely not. And I'm about to lose connection because Ashley needs to get back in. Give me a second. So Nick said 4 over x minus 7. Sure, why not? How about 5,450 over x minus 7? I just so made that up. How about the easiest kind of function? 1 over x minus 7. But what you cannot say is 0 over x minus 7. Why not? Because that's 0. So, okay, so cool. Now while I'm getting out and back in, give me a function that has the domain, one more time, -infinity to -2 union -2 to infinity. And I'm going to admit Ashley, and we know what happens. Okay, I think she's in. So write down a function. Where are we? Here we are. Danielle says a function of 2,222 over x plus 2. Yes, that is exactly correct. And I say 15x to the 7 plus 3x to the 5th minus 6x to the 4 plus 3x3 minus 2x squared plus x minus 5 over x plus 2. How about that one? Beautiful. This one has a domain of, well, what I wrote down. Okay, now real quickly, when you find the RV, like I said, you do not have to graph it, but I want to show you if the RV is -4, that means there's a gap at -4. There are a couple graphs in the book. There would be a gap at -4 on this green vertical line is called an asymptote. In case you go on Netflix and you do Netflix trivia, as I have discovered yesterday, I did my trivia knowledge on music and I got it all right. Here you go. Yeah. Anyway, so in case you're being asked, this vertical line is called an asymptote. You will graph this in college algebra. I don't want to get more into it. And we're skipping over that. Now we're going to reduce, because we're talking about rational expressions, and rational expressions, like I said, we do all the arithmetic as we know with regular fractions, we do now with rational functions, expressions. So let's remember how we reduce fractions. If there is a factor that is a common factor to both numerator and denominator, then we are going to reduce it. Now we can either factor it, and that's what we actually do later on. The 2 can be factored 2 times 1, and the 8 can be factored 2 times 4. And then we reduce the factor we have in common. And please, let's not say cancel anymore. You know what I mean? Reduce means 2 goes into 2 ones and into 2 ones, and the answer is just 1/4. 25 over 35, if we reduce this by 5, because 5 is a factor to both of them, you get 5 over 7. So really what we know, like mentally, we know how to reduce it, we actually factor it. Now, if the numerator and the denominator is the same, like 3x over 3x, we reduce that to what? Say it loud. 1. What's 5 over 5? Students, 5 over 5 is 1. Yes. What's x over x? 1. What's x plus 1 over x plus 1? 1. If the numerator is exactly the same as the denominator, it reduces to 1. And that's our goal. So, before we get to our first problem, how would you have this problem not on a test? What would you do first here? Would you go ahead and say, oh, 2 goes into 4 2 times, and 3 goes into 6 2 times, and I don't know, you get a 4 here somewhere. Is that what you would do? Oh, Jordan shaking her head. No, 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 no. What you need to do is you need to do the arithmetic first, which gives you 5 over 10, and now that can be reduced, right? To what? 1/2. So if there is a plus or minus in between your terms, and that is the biggest mistake in chapter 5, you cannot cancel. Here I said the word. You cannot reduce until you have the answer or you have multiplication. If this would have been, I get so excited over this stuff. 2 times 3 over 4 times 6, now I can reduce it. Oh, 2 goes into 4 2 times, and 3 goes into 6 2 times. But you know what sometimes students forget? They say the answer is 4. No, it's 1/4, because when you reduce it, you get a 1. So what I'm trying to tell you, and this is important, this is the most common mistake. You cannot, let me give you an example. X plus 2 over x plus 4 cannot be simplified. Why not? Because there's a plus in between. You are not ever, ever, ever allowed, if you listen to this video again, please listen to it. to reduce if there's a plus or a minus between terms. That is not allowed unless they are the same. So be careful about that. Okay, number 32. Why did I write that down? I want to do 32. I want to go to our first problem. Now we're simplifying. We're simplifying rational expressions. And what does that mean for us? So this problem, I'm pretty sure I got out of the book, is number 37 on page 388. So don't even think about it. Oh, 9 goes into 18 twice. You can't do that because there's a plus between the 6 and the 18 and the 9 and the 27. So the first step, I wrote it down here, is factor numerator and denominator. And you see now why it is so important to know how to factor. How do we factor 6a plus 18? Anybody? And again, these are just common GCF factoring methods problems. 6a plus 18. How do we factor that? GCF and all. What do they have in common? Anybody listening to me? Hello? Out there in the... They have 3 in common, but 3 is not the greatest common factor. 6 and 18. What is the greatest factor? 6. We have to factor out a 6. And then what goes in the parentheses? A plus 3. And now we factor the denominator. What is the GCF for the denominator? People here said 9. Mark says 9. And what's in the parentheses? A plus 3. Guys, are you with me? We're factoring. And this is a simple GCF problem. So we factored numerator and denominator. Step 2 says reduce common factor to 1. So now we have multiplication between the 6 and the a plus 3 and 9 and the a plus 3. We are now allowed to reduce. What is the common factor? The a plus 3, and they both reduce to 1. So all we have left is a 6 over 9, and step 3 is check if you can simplify this further. In other words, reduce it further, and this can be done to 2/3. We're reducing by 3. And that is simplifying rational expressions. You have to factor numerator and denominator and then see if there's anything in common that we can reduce. Are you with me? How about number 38? 38 says, where is it? 5y minus 15 over 3y minus 9. And again, I'm trying to tell you the factoring methods that you want to review are GCF, squares, trinomials. 5y minus 15, Elijah give me an answer. I don't know if it's right, but we'll find out. How do you factor 5y minus 15? The GCF is 5y minus 3. 3y minus 9, how do you factor that? 3, and in parentheses you have y minus 3. Now what they have in common is a y minus 3, and Elijah changed into whatever we have left now. 5 times 1 is 5, over 3 is the final answer. Questions? Okay, thank you very much. Yes, Elijah, I like it. 39. X minus 5 over x squared minus 25. Factored. X minus 5 cannot be factored further. There's nothing you can do, so bring it over. X squared minus 25 factors into
X plus 5, x minus 5.
that is a difference of 2 squares. I'm going to say it one last time. You see where the factoring is important now? X minus 5, x plus 5. I highly recommend that you start with homework in 5.1 now and ask questions, and don't wait until we have a test, which I cannot tell you when that will be. Now, what can I reduce here? Common factors. People online, the common factors that I can reduce are the x minus 5, Nick, yes, and put the 1 down. Every time you reduce something, you may want to get used to there is a 1 there. Because otherwise you may tend to forget it and write down as answer x plus 5. But what actually is the answer? 1 over x plus 5. So be careful about that. Whenever you reduce with common factor, you will see me putting down a 1. So I know we're so used to, oh, we cancel and they go away. They don't go away, they reduce to 1. Now here, number 44, we have a trinomial. Luckily for us, this trinomial has a leading coefficient 1, which means we can put our parentheses down. We also can put our y's in here. When the leading coefficient is 1 for the numerator, we're looking for 2 numbers that multiply to -9 and at the same time add to a +8. Which are those 2 numbers? Elijah says 9 times -1, and that is correct. Hold on, let me slow down for a second. So we would put a +9 here and a -1 here. For the denominator, we're looking for 2 numbers multiplied give me 4, but at the same time add to -5. And Danielle says, what do you say?
-4, -1.
-4 times -1, -4, -1. Again, which order you write them doesn't matter, but the whole reason behind this exercise is to reduce. So it's a good chance that you gotta have the same factors, numerator and denominator. We're gonna reduce the y minus 1s because they are the same, And the final answer is y plus 9 over y minus 4. And don't even think about it. Oh, can I not cancel out the y's? No. Why not? There's a plus and a minus. Yes, thank you, thank you, thank you. Yes, this is fun stuff. I wish I could see your faces when I said that. Okay, are you ready? Not for this one. I don't want to do this one. Well, let's skip over this one. Let's be ready for 2 minus 3 over 3 minus 2. What is that equal to? Well, if we do the arithmetic in the numerator, we get negative 1. 3 minus 2 is positive 1. So the answer is negative 1. Why am I showing you this? Well, there's reason behind it. This is subtraction. Let's take a look about addition. X plus 2 over 2 plus x. With addition, it doesn't matter which order I'm at, right? The order can be reversed. It's called commutative property. It's still the same. Doesn't matter if it says x plus 2 or 2 plus x. If we were to reduce it, we would get a 1, right? They're both the same. However, as you can see with the top example, that doesn't work with subtraction. Subtraction is not commutative. 4 minus 2 is 2. 2 minus 4 is negative 2. So they are not the same. If you divide it, you get a negative 1 as well. So how do we reduce subtraction problems that are not commutative? X minus 2 over 2 minus x, they always reduce to negative 1. Because really what happens is, from chapter 4 again, you factor out a negative 1 in the denominator, and then you get a positive x and a negative 2. Then you could reduce the x minus 2's, and you have a negative 1 left. So that's the reason behind it. So subtraction, if the order is reversed, 4x minus 1 over 1 minus 4x, that reduces to negative 1. What time is it? Well, let's do a problem. Let's take a look at this simple problem here. It's number 60 in the book. Factor. So it says simplify means we have to factor if we can. 5p minus 10. We can factor out a 5. And we have p minus 2 in the parentheses. The denominator cannot be factored, that's just 2 minus p. Now, based on what I just told you, and my rule of thumb is the p minus 2 and the 2 minus p, they reduce to negative 1, and I always put the negative 1 in the numerator. Always put it in the numerator, and then you have 5 times negative 1 left, and the answer is negative 5. Right. So when you reduce it, reduce and put your negative 1 in the numerator. Let's do one more, and then we have time's up. 73. No, I don't want to do 73. This one here, 71. X squared minus y squared, simplify, over 8y minus 8x. X squared minus y squared is a difference of 2 squares. How do we factor that?
x minus y, x plus y.
Remember what we did in class? X, y, y, we took the two in the middle, x minus y, and then we get x plus y. How do you factor 8y minus 8x? What's the GCF here? 8. And that would be y minus x. Elijah, what are you writing? X equals y. Okay. X plus y is not the answer. Now what can we reduce? X minus y and y minus x, what does it reduce to? -1. So what's left here is a -1 times x plus y all over 8. Maybe x plus y, oh, I see now. Elijah, I got now what you meant to say, but you forgot one thing, and that was the -1. Be careful about that. X minus y and y minus x, they are reduced to -1. Now, if somebody wrote -x minus y over 8, that's correct as well. However, I know what's coming, and I want you to keep it in factored form. So leave it just as you see it, like so, and that will be fine. Do not distribute the -1 or whatever, because when we add and subtract rational expressions, we don't want to. We keep it in factored form. Okay, unfortunately, we don't have time anymore. That is it. So we are done. That's really 5.1. It's done. So look at it, and maybe on Friday you can ask me questions if you have any. And then we continue on with 5.2. You can email me, talk to me, whatever concerns you may have. Goodbye. I will, like I said, post the tests hopefully by Friday, and also give you the test corrections. Okay. See ya. Stop recording.